Okay, so let's unpack this. When you think about calculus,
Mhm.
differentiation, integration, all that, your mind probably goes to, I don't know, rockets, maybe bridge building.
Right, the usual suspects. But what if I told you those exact same mathematical tools are actually key for deciding something, well, seemingly much simpler,
Like what?
like when's the best time to cut down a tree?
Seriously. Calculus for logging.
It's uh it's really fascinating actually. This is where abstract math makes a direct connection to managing real-world resources. We're talking about forest resources technology, specifically using calculus concepts. It helps figure out not just if you should cut timber, but the most efficient, or as the sources put it, the optimal time to do it.
Okay, so this deep dive then is all about exploring that exact connection, how we get from, rates of change and sums to making these really practical decisions out in a forest using the source material you've looked at.
Precisely. Because managing a forest, well, for the long term, it's more than just watching trees get bigger. You've got to think about growth rates, um, market prices, harvesting costs, environmental impacts
Yeah.
over years, decades even.
Right, it's complex.
Yeah, and finding that optimal harvest time, that's crucial. If you want to maximize your yield or profit or whatever goal you've set, it's really about hitting that biological and economic sweet spot.
And you're saying this isn't just like based on experience or tradition. Calculus gives you a hard number, a specific moment.
That's definitely what the source material points towards.
Yeah.
Take differentiation. Its whole purpose is finding rates of change,
Right.
right? And locating maximums or minimums on a curve.
Okay.
So if you can model the value, or maybe the volume, of timber over time,
Okay.
differentiation lets you pinpoint where that value peaks, or maybe where the rate of increase slows right down.
Ah, so it tells you when growth isn't as efficient anymore, economically speaking.
Exactly. It flags that potential optimal point before you hit diminishing returns.
Okay, that makes sense for differentiation, finding the peak or the slowdown. What about integration then? Adding things up. How does that fit into deciding when to cut?
Well, integration is all about accumulation, the total amount over time. So in forestry, you might use it to calculate, say, the total volume of wood grown over 50 years,
Mm.
or maybe the total costs of maintaining the stand versus the total potential revenue you'd get if you harvested at year 50.
Okay.
Integration helps build that complete picture, the stand's whole development and value story up to a certain point in time.
I think I'm getting it. So integration gives you the big picture, the total accumulation curve, and then differentiation zooms in on that curve to find the specific critical point, like the point that achieves whatever you're aiming for, maximum return maybe, or peak volume.
You've got it. Differentiation finds that key moment on the curve that integration helped you build. And, this brings up a really important question our source material touches on. What are you optimizing for? Is it just the most wood or the
Mhm.
highest profit or maybe minimizing environmental impact?
Ah, right. The optimal time depends on the goal.
Exactly. And the power of using calculus here is that you can actually build different models for these different goals. And then you mathematically solve for the time that best achieves that specific objective.
Wow. It's pretty remarkable how these foundational math concepts become such practical tools. You're literally using the mathematics of change and totals to make informed decisions about harvesting a natural resource.
It really transforms what could be a very complex problem, with biology, ecology, economics, all tangled together. It turns it into something you can quantify, something you can solve with more precision, moving beyond just estimation towards calculated strategy.
Okay, so let's try to wrap this up. This deep dive really highlighted how calculus, differentiation, finding those key moments, integration, measuring the total picture over time, gets applied directly in forest management. It's used to help pinpoint that mathematically best time to harvest timber. It really reinforces how mathematics gives us these frameworks for finding optimal solutions in resource technology.
Absolutely. It underscores that mathematical modeling isn't just academic. It's a critical tool for managing resources efficiently and hopefully sustainably.
So thinking about this, if calculus can help pinpoint the precise best moment for timber harvest, considering all those complex factors, where else might we need this kind of mathematical deep dive for managing natural resources? I mean, think about fishing quotas or water use in farming or even timing investments in the energy grid. Could finding the best time or the most efficient method in those areas also rely on a similar mathematical approach? Something for you to think about.